So today we're gonna finish section 7.1. This section is not on exam 3, but of course it's on your final. It just is it's important. If anything, it's more important because the final was 200 points, right? Now, hopefully we have a few minutes after we done the section 7.1, and then I'm going to highlight the problem for you, okay? This weekend, I'm going to do a review, and I'll send out a video review to you. Let's start section 7.1. Before we start anything, I'd like to remind you some of the distinction between expression, identity, and equation. Students often get confused with these. When I give student expression, they tend to set it equal to 0 and solve. I don't know why, they just really tend to do that. So what's the difference between expression versus equation? Expression does not contain the equal sign, right? The only one side. When simplify an expression, do not set it equal to 0. Whatever you're given, that's what it is. If you can simplify, go ahead and simplify. If not, leave it as is. Right? Do not try to solve. It's not equation. If you multiply the expression by a fraction, that fraction must be equal to 1. What does that mean by that? So for example, if I have 5/3 plus 2/5, if I want to add the two together, I have to have a common denominator, right? So the first fraction, I need to multiply by what? 5/5, right? And then the second fraction, I need to multiply 3/3, right? A lot of time I see people just multiply the bottom and then they forgot to multiply the top. What they meant is whatever you multiply, it has to be 1, right? 5/5 is 1, 3/3 is 1. So you don't change, right? You just kind of triple it or make it bigger, right? But you don't change the value. Identity. An identity is kind of similar to an equation. The only thing different between identity and equation is that you don't solve identity. You try to prove that the left-hand side equal to the right-hand side. So first and foremost, identity contains an equal sign. Right? So it's not an expression. It is an equation that's true for every value for which it is defined. But you're not solving for it. It is an equation, but you're not solving for anything. When you prove an identity, one side is transformed into another side. Usually if I pick the more complicated side and then I transform it into the simpler side. So I prove that two sides are equal, right? Because they say that it is identity, then left-hand side has to be equal to the right-hand side, right? So here you prove left-hand side equal right-hand side. Do not solve. When proving identity now, here are the rules. When proving identity, never cross multiply. You just gotta pick one side and then transform it, manipulate it, or whatever you need to do, manipulate it, right? Into the right-hand side. Never perform the same operation on both sides. That means you're doing equation things. You solve them. Usually you pick the side of an equation that appear more complicated. The more complicated, the better. You have more things to work. So for example, if you look at this example right here, sin x times secant x equal tangent x, I need to prove that sin x times secant x is indeed equal to tangent x. Right? So I'm gonna pick the more complicated side, which is the left-hand side, right? And usually when you see secant, cosecant, cotangent, tangent, I would recommend you rewrite it as in terms of psi or cosine or both. I'm not gonna go through all the proving here. I'm just proving my point that pick the complicated side, that's all. We'll have plenty of problems to do this. Now, equation is true for certain value of x. So equation that you solve for a variable as opposed to identity, you don't solve, but you prove. Not all values that you come up with will be the solution of the equation. So sometimes you have to check. How do I solve a trigonometry equation? First, we're going to use identity to rewrite the equation in terms of a single trigonometry function. Use rule of algebra. You use a lot of rule. Whichever rule you need, whatever you have, whatever you know, just bring it all out. There's no 1, 2, 3 here. I know they put 1, 2, 3, but there's no sequential step. Okay. When I take this class, I remember undergrad is my favorite one. It's just so cool. I don't like little. I don't like arctan sector area, all that. It's just needy little thing that I have to take care of. But this is my favorite. It's more like algebra-ish. So here is all the trick thing that you need to know on your exam. I forgot what they give you. This weekend, I'm going to send you the sheet that you are given on the exam, okay? So you know what to expect. Whatever you're not given, you're supposed to memorize. Right? I think they give you all of these. I forgot. I have to take a look again. All right. Simplify. Let's simplify some trigonometric function. Again, there's not solving here. Please do not set it equal to 0. I know it's tempted, but don't do that. Psi. Now, the function, even function are cosine and secant. It's very easy to remember. I'll tell you my trick. That's even identity and odd identity. So even is when you have a negative in the angle, it's disappear. And I'll tell you why. You don't write this down. It's just say here. Here's my theta. And here's my negative theta. They equal, right? What do you notice? They have the same what? They have the same x value, yeah? Right? Even, I don't care, you pick the positive angle or negative angle, because it's quadrant 1 and quadrant 4, x-axis is positive value, right? So cosine is positive. So if you see cosine of negative t, cosine of negative theta is automatically become positive, right? Because the two outcomes are the same. They are the same. You don't believe me? You can try cosine of, say, 30 degree. Cosine of 30 degree is √3/2, and cosine of negative 30 degree is still √3/2. So they're the same. Cosecant, I'm sorry, secant is just the reciprocal of cosine. So it's automatically even. So there are only two even identity. Does that make sense? Easy to remember, but it's just cosine, and then secant is a flip of cosine, so it has to be even. The odd one is sine, cosecant, tangent, and cotangent. You notice all of these, they contain what function? Well, sine is this contain sine. Is cosecant contain sine? Yes, right. Is tangent contain side? Cotangent, yes, right. So all of these functions contain side, right? So odd identity. So that's how I remember it. You can prove this by trigonometry as well. I'll keep my thing. So here, for example, let's do psi. Let me erase that. You can see psi of theta is positive, say 30 degree here. Is 1/2, right? But psi of negative 30 degree is negative 1/2. So what you do is when you have a negative angle, it looks like you factor out the negative to the front, does it? Just to remember it like that. I know it's not true, but that's how I remember it. It's, if you have an odd identity, you kind of factor the negative to the front. We took care of that. Let's do this one. So psi negative x is odd, so it becomes negative psi x. Cosine is even, so it just become turn back to cosine x. Cosecant is odd, so negative cosecant x. There are between functions psi, cosine, cosecant, the multiplication. There is no multiplication between those x. Right? Those are part of the function. Claire, I'm going to mute you, okay? Because I'm echoing. Thank you. So negative psi x. Negative become positive. Is that okay? Can I just remove that? Time cosine x. Cosecant is the same thing as 1 over psi x, yeah? Psi x cancel. So it's equal to cosine x. Why don't you guys try number 2? Very good. Okay, now we have a complex fraction. When you divide complex fraction, you split multiply. Do like algebra. Do things like you do in algebra. Yes. So cosecant, you want to divide it in half. Well, it's a variable. The whole thing is a variable. We're not solving it. So I would recommend you divide cosecant into something. Just divide, like I said, every time you see something like weird, divide it into itself. Or cosine. I think a lot of people like nervous because they see trig function. It is think of cosine x. It's like, you know, it's just a variable. Like think of it as just x, like big X. Maybe it help ease your mind a little bit. So cosecant x, I'm going to rewrite it as 1 over sine theta. Oh, I'm sorry, I say x. I meant theta. Secant theta is 1 over cosine theta. That's the top. Over cotangent is cosine theta over sine theta. Most of people get that far, right, which is good. On the top, it's the same thing as what? 1 over, when you multiply two fractions, you just cross multiply, right? Sine theta times cosine theta, right? And then if you divide a fraction, what do? You flip multiply, right? So time sine theta over cosine theta. Everybody okay with that part? Sine and sine cancel. Then I have 1 over cosine of theta, all of that square. Or better yet, 1 over cosine theta, all of that square. One square is still 1. Right? What 1 over cosine theta equal? Secant, right? So secant theta, all of that square. Done. By the way, secant theta, all of that square is the same thing as, is equivalent to secant square theta. These are the same thing. So you can give me either this answer or this answer is the same thing to me. Notice that the square is in the secant, in the letters, not in the theta. This is, you don't have to write this down, but this is different than secant and then theta square, right? The theta being square, but not the whole thing, not the whole function, right? Number 3, same thing, right? Same thing. You, every time you see tangent, everything you see that not sine, cosine, you convert it to sine, cosine. Okay, so tangent is sine of x over cosine of x times sine of x plus secant is 1 over cosine of x times cosine of x, all of that square. They put cosine square x, but I like to put the cosine of x, all of that square, so you can see. Now, it is very tempted for you to cancel. You might tempted to cancel this one with this one. It's fine. Go ahead and do that. I want you to get it wrong, but then you stuck, right? You cancel what I'm going to do next, and then you stuck. What I'm going to do is, I see the common denominator, right? So I'm going to add the top together. Sine x times sine x is sine x, all of that square, right? Plus cosine x, all of that square, over the common denominator, which is cosine of x. What the top equal to? 1. That's the thing that you should, if you forget everything else, that's the only one thing that you should remember, at least remember that one. Sine square x plus cosine square x is 1. Remember the, yes. How come we don't have two cosine in the denominator? Oh, so here is I don't know what you meant, but I think that's the first fraction. This is the second fraction. Maybe I'll do one more step. No, I don't combine the denominator. It's the common denominator, so I'll keep it the same. So what I did was, so the top is, the first one is psi x times psi x over cosine x, correct? Yeah. The second one will be cosine x, all of that square over cosine x, yeah? If you have 3/2 plus 5/2, what do? You add the top, right? That's one, which is equal to 1 over cosine x, which is secant x. Try number 4. As much as you can. I'm not expecting you to come up with an answer, but as much as you can, yes. Mhm. Yeah. My Zoomer, you should do the same if you're around. Today, lecture is not on. Oh, okay, very good. So now you. Right. So now, how many sides are on the top? 3 of them. 1 over the bottom. There's how you execute and go. That's when we have the sides for x. Not yet. Go ahead. 1 second. Very good. You almost there. The last part. I would recommend you catch up. Yes, yes. No, the Q only applies to the sign, not the pieces. Oh, the negative is gone because cosine negative x. Most of you got the first step right, but you gotta understand what you write though. That's why you stuck on the next step. You don't understand what you wrote writing. Now 3 sine cube x. I like to rewrite it at 3 sine x, and then the sine x is, I like to do it like that. It's the equivalent thing. It's the same thing. Cosecant x is 1 over sine x. Keep going. Plus cosine square x, right? Plus cosine of negative x turn into cosine x, right? So it's a cosine x times cosine x is cosine x, cosine square x, right? One of the three here cancel the sign in the bottom, yeah. You have 3 of them on the top, you have 1 on the bottom, you cancel. So equal 3, 3 stay the same. Sine x, all of that square, right? Or better yet, if you want to rewrite it, you can say 3 sine square x is the same thing. However you write it, it's equivalent. D2 right here was equal to 1 plus 2 is 3, right? So that's 3 cosine square x plus I see you guys treat this as 1 and this is 1. Then 3 plus 3 is not you have to factor out what? The 3, right? If you want trig identity, you're gonna factor out the 3. So I have sine square x plus cosine square x. That one equal to 1 because of this. Three times 1 is 3. Number 5, did you try 1? Secant negative x is an even function, so it becomes secant x, yeah. It's even function. Let's rewrite this. Cotangent x is turned into cosine x over sine x. Tangent x is turned into sine x over cosine x. Instead of divide horizontally with the secant x, can I say it like that? I like to write like this. You know what? Go ahead and write it like that. I don't want to make another mistake. That's another mistake you might make. Over 1 over cosine x. Yeah. So far so good. Everybody got that step. 2 points. 2 points. What do you think I should do next? What do you think you do next? Don't be afraid to be wrong. Yes. Hmm? Before that, you only, huh? No, you can't. You can't. Well, you only cancel if you multiply. There's multiplication between the top, right? There's plus. Can't cancel anything. What? Yeah, just take care of one thing at a time, right? Take care of the top first. You need to turn the big top here into one fraction. Then you flip multiply, right? So let's take care of the top first. What is the common denominator of the top? Psi x cosine x, right? So the first fraction missing cosine x. So what I'm going to do is I'm going to multiply the first one by cosine x over cosine x. Basically, I multiply by 1. I didn't change. The second one is psi x over psi x. Now I have a common denominator. Now is cosine x times cosine x is cosine square x, yeah? Psi x times psi x is psi square x. And please put the square in the right order. I do not want to see the square on the x. That will be wrong. That's mean different things in math. Right? That means the only thing being square is what? The angle, right? Not the whole function. What's cos over? Let's see. Over the common denominator would be psi x cos psi x. Just take care of one thing at a time. What's cosine square x plus sine square x equal? 1, but thank you. That one equal 1. So I have 1 over psi x times cosine x. So that's the top. I just took care of the top. Now the bottom, just kind of rewrite it. Just put it over 1 over cosine x. There's nothing we can do with the denominator. It's pretty simple. Now I can flip multiply, right? Now 1 over time, instead of divided by 1 over cosine x, gonna times psi x over 1. Now I can cancel to the multiplication. Any question, please ask. Don't think too hard, just one step at a time. One step at a time. Seven is your U try 2. I want you to try number 8 as much as you can. Talk to your neighbor. Talk to me. Ask questions. Zoomer, am I I sign out. I'm gonna stop sharing. I'll reshare. Anyone have an answer? Yeah, go ahead. Don't stop. No, don't stop. Take care of one thing at a time, like I said. Take care of the numerator first. Forget about the denominator at the moment. You get partial credit for everything you do. Don't stop. Don't be afraid. You gotta meet 130. Oh, you try it too. Okay, okay. I will try to join the person. You can move things around if you can. If you guys have an idea, right? One thing at a time. One thing at a time. Yeah, that's right answer. Good for you. And you're going to get wrong a lot of time. I did. And that's how you learn. I want you to be wrong with me, not on the exam. I see people cancel the one with the one. Please don't. At this level, I don't want to see that kind of cancellation. 1 plus psi x over cosine x and over 1 plus cosine x over psi x. Take care one thing at a time. The first fraction missing cosine x for the first term, right? So I multiply top and bottom for the first by cosine x over cosine x, which is 1. And then you add across cosine x plus psi x. On the bottom is now common denominator, which is cosine x. We're done with the top, right? For now. Now take care of the bottom. Same thing. You need to make it into a common denominator. So psi x divided by psi x. Basically multiply by 1 again. Now you have a common denominator, which is psi x. All you do is just add the top. Psi x plus cosine x. You have one fraction on the top, one fraction on the bottom. Now you can flip multiply, right? It has to be one fraction. So cosine, instead of cosine x, can I rewrite it sine x plus cosine x? Is that okay? I'll rewrite it same. Cosine x plus sine x over cosine x, that's the top, times, now you have to flip the fraction in the bottom. So sine x here on the top, and then the bottom sine x plus cosine x. Cosine x plus sine x is the same thing as sine x plus cosine x. So they cancel. It's like you have x plus y over y plus x. So sine x over cosine x is tangent x. We do number 9 together. You tell me what you think though. Just step one step at a time. What would you do the first thing on number 9? Just tell me what you think. Yes, very good, right? Before that, I will eventually, but before that, you know what? Just let her go ahead and do what she said, which is right. It doesn't matter what step first. So rewrite it. So secant x is going to be 1 over cosine x. Cosecant x will be 1 over sine x. Let's do that so you get partial credit. Sine x, I like to rewrite sine x over 1. Is that okay? Everybody else a fraction. Might as well turn that 1 into a fraction. Plus cosine x over 1. Excuse me. Minus 2 minus cosine x over sine x. Equal to 2 over 1 if you want it like that. What should I do next? Now that you turn into sine cosine, what do you think you do next? Distribute, right? Just do whatever you think you can be able to do next, right? I really don't know what to do next, really. Whichever way I can moving forward, I'll just kind of do it. You multiply that with that. I'll do it slowly. So that will be sine x over cosine x. Is that okay? That's why I turned the sine x into a fraction sine over 1. Maybe we shouldn't. Oh, leave it. It's fine. Next one. The outer foil. So outer, that's the O. Is it cancel? Just 1, right? Thank you. That's just 1. So plus 1. What about this one? Same thing, right? Plus 1 again. What about that one? The last one. Yeah, it's just one step at a time, right? Minus 2 minus cosine x over sine x. Can I cancel the 1 plus 1 with the negative 2? Right. What else can I cancel? Yeah, I can cancel that one with that one. What leave me is just sine x over cosine x. Tangent. I missed the s here. See, one thing, it's very easy. One thing at a time. Don't think too many steps ahead. It'll drive you crazy. Because you never get right if you do like that. You get wrong, you do it again. I want you to try number 10 to get on your own. Just write out as much as you can. Take care one fraction at a time. Go ahead and do it. It's good. I'm glad you do it. So you know that you're stuck. Stuck. Right. I like it. No, do not. Please take practice. So here you see one big fraction. She said, yeah, that's what she said with this fraction. Now she took care one at a time. Very good. That's what it's about. Now take care of this fraction. Correct. But I played you wrong. But you just said. Yeah, okay, I'm sorry. If you're stuck, do it again. That's fine. You're supposed to be stuck. If you're not stuck, you shouldn't. My Zoomer, anybody have an answer you want to put in the chat? Tangent is, yeah, that's okay, Amber. Thank you, Amber. At least everybody got the first step, right? So tangent x is the same thing as sine x over cosine x. All of that over. I always write my main fraction to be bigger, right? Just to separate with the little one. Cosecant square x is the same thing as 1 over sine square x. Tangent x again, sine x over cosine x. All of that over 1 over cosine square x. 2 or 3 points to do that. Now, if you notice that the number 10 and number 9 is slightly different, or number 10 and number 8. Number 8 only how many big fraction you see on number 8? One big fraction, right? Something over something. And the top it have 2 little fractions, the bottom have 2 little fractions. Now, as for number 10, you have how many big fractions? 2 complex fractions, right? Instead of 1 like number 8. So these are 2 separate things. So what I'm going to do, I'm going to take care of one thing at a time. I'm going to take care of the first one, and then I'm going to take care of the second one. So let's do that. Sine x over cosine x divided by 1 over sine square x is the same thing as multiply, yeah? Sine square x over 1. Which is sine cube x over cosine x. Everybody okay with that? Sine x times sine square x or sine cube x. So far so good. All right, so I'm kind of simplified that one. Let's take care of the second one. Same procedure, right? So it's going to be plus sine x over cosine x times reciprocal of 1 over cosine square x will be cosine square x over 1. Sine x times cosine square x is sine x times cosine square x over cosine x. The main thing is what? We have common denominator, right? I know it looked kind of weird, like, oh, I don't see identity on there. That's okay. Not yet. It will be. Right? Can I add the top? Bring it to 1 in 1? Like that. I'm just rewriting it under 1 common denominator, that's all. Nothing special. Oh, I forgot the cube. It's cute. So far, so good. I just bring it into 1 fraction. What do you think I should do next? What do you think you do next? No. You cannot cancel. Remember, you have, say, for example, x plus y over y. Can you cancel the y? I hope not. No, don't do that, right? No, because between them, there's the marry, right? Do not split them. Otherwise, you'll be a home wrecker. So what do I do next? Huh? There's no like term. There's 2 different things. What do I see? Is there a common thing between those 2 terms? Yeah, psi x, right? Factor. I told you, factor will come back to you by in the month because it's always, even in trig, right? Always there. So I can factor psi x. What's left for the first term? How many left? Yeah, psi square x. Second term psi x1, it's just cosine square x. All of that over cosine x. What is it equal to? 1. I told you it will be. It's just you have to massage it a little bit more. Sine x over cosine x, that's your tangent x. By the way, it's not all problems, it's not all tangent x, okay? It's just coincident that it's kind of turn out that way. You try 3 will be your number 11. I make you all of the you try do on Sunday night, I think. Because it's not on exam 3, I'm not in the rush, right? You try 3, it will be kind of similar-ish to you to number 12. It is harder than the first you try though. Just give you a heads up. That's number 12. So I can tell you what's on the. Bless you. Oh, number 12. What do you think? There's no cotangent. There's no tangent that I can flip. What do you think you do? Common denominator, right? Is it the only thing that I can think of is common denominator, really, because I need to combine those two. So let me rewrite this. So psi x. I'm just rewriting the problem. So I have some room. Minus psi x over 1 plus psi x. What is my common denominator? What should I multiply the first one by? Yeah, 1 plus psi x over 1 plus psi x. Remember that. Expression is 1 minus psi x. I would put the parenthesis around those. Let me check mine. Now the bottom is just 1 plus psi x times 1 minus psi x, right? Let's take care of the denominator first. I like to take care of one thing at a time. Subtract. No, it's common denominator. Common denominator, yes. I like to take care of the common denominator first. What's 1 minus psi x times 1 plus psi x equal? A minus b times a plus b equal a squared minus b squared. You guys remember this? Right? So that's your a, that's your b, that's your a, that's your b. A plus b times a minus b. So 1 square minus psi square x, right? Or you can FOIL it. 1 minus, so psi 1 square, which is 1, minus 1 minus psi square x. Or you can FOIL it, and then you see the middle terms, they cancel. I'm just showing you another trick that you can do. Make it faster. All right, so I think I'm done with the bottom. One square is still one, so I will erase that little square. Now I'm going to take care of the top. Can I distribute the top? Psi x times 1 is psi x. Psi x times psi x is psi square x. I'm doing the same thing. For the, be careful. There's a negative in front of psi x. I'm going to use that one as well, right? So negative psi x times 1 is negative psi x. Negative psi x times negative psi x is positive psi square x, right? That one and that one cancel. On the top, how many psi square x do I have? 2, right? 2 psi square x. I lied to you. I didn't finish the denominator. I should. For the denominator, you have to look at for the Pythagorean identity. This one. If I subtract psi squared t, both sides, do you agree this will cancel? What's left? Yeah, cosine squared t equal 1 minus psi squared t. So indeed, this little thing right here, the denominator is equal to cosine squared x. Because we derive another one from the Pythagorean identity. Let me rewrite the top. 2 psi squared x over cosine squared x. Cosine over cosine is tangent, right? So 2 tangent squared x. Okay, so I don't have time. So I'm going to make a video review include with the highlighted problem, okay? So you can watch it later today. I say I'm gonna highlight for you because we don't have time. I'll send out email right today. Bye, Zoomer. Questions?